All right, the objective of this lesson is to talk about solving absolute value equations and inequalities. When we've solved absolute value equations, we want to know the distance from that x is from exactly a units in this situation up here. So on a number line, we go ahead and draw a number line. We've got x, and we're going to go a units. Now when we're talking about an equation, it's just 2 points. And so we never really graphed an equation because there was no point to it. You either get x equals a or x equals the opposite of a. When we have the absolute value of x is less than a, then we want to know the distance from x to 0 is less than a units. So if we have a number line and x is in the middle, we go a units either to the right or to the left, which makes it the opposite of a. And we want to make sure that we're in between, that our distance is less than a units away. As an inequality, it looks like a compound inequality. The opposite of a is less than x, less than a. When we have the absolute value of x is greater than a, we want to make sure that we're further away. So we have a number line. X is in the middle. We have a units to the right and a units to the left, which we say is the opposite of a. And if we want to make sure that we're further away, then we want to make sure that we're going away or outside of it. In other words, this looks like an or situation, where x is less than negative a or x is greater than a. We've got an or in the middle if you want to think of a rowboat with the oars facing outward. And then with the and situation, sometimes we think of 2 endpoints and everything in the middle like a sandwich. So back to absolute value equations. When we have an equation and we have this quantity on the inside is equal to c, we make it to the opposite. So we take 2x minus 6 equals 8, and we keep 2x minus 6 the same, equals the opposite of 8, or negative 8. This creates an or situation. We solve each of these inequalities by adding 6 to both sides, dividing by 2, and we do the same thing on the other side, except the numbers turn out different. We add 6, we divide by 2. Either one of these answers will satisfy the absolute value equation. When it comes to absolute value inequalities, if it's a less than situation, we create a sandwich type or compound inequality where 2x plus 6 is less than 10. We're going to make this also the opposite of 10 or negative 10. And we're going to go ahead and put it on the left-hand side. And we're going to make 2x plus 6, we're going to make that greater. Notice it still ends up being the less than symbol. We kind of did flip it though. If it's more comfortable for you, you're welcome to write 2 inequalities. One is 2x plus 6 is less than 10, and 2x plus 6 is greater than negative 10. Remember, anytime we make something negative, we flip the symbol. It's the same idea with absolute value inequalities. This one's a little bit more condensed in solving, I think a little bit easier as well, but some people prefer the and where it's split up. In this situation, whenever we subtract 6 from one side, we're going to subtract 6 from all the sides. So we get negative 16 is less than 2x is less than 4. Then we divide everything by 2. We get negative 8 is less than x is less than 2. When we graph this on the number line, we've got negative 8, and we've got 2. And x is, let's start with the 2. X is less than 2, so we're going to start shading to the left. At the same time, x is bigger than negative 8, so we're going to shade to the right. Again, we've got a less than situation, which is an and situation, which reminds us of a sandwich on our graph. And letter B, when we're solving this inequality, it's an or situation. An or situation cannot be compounded or written small. So we've got 3x minus 1 is greater than or equal to 11, or 3x minus 1 is less than or equal to negative 11. Make this a little bit bigger. In the or situation, we solve both the inequalities independent of each other. So we add 1, we divide by 3, or in the other case, we add 1, we divide by 3, and then we graph this on our number line. We put the smaller number to the left, the larger number to the right. When we're dealing with x is less than or equal to negative 10 thirds, that shades to the left. and x is greater than or equal to 4, we fill that in and shade it to the right. Again, we had a great Taurus symbol. We think of oars on a rowboat that are pointing outwards. In the letter C, we have an absolute value inequality that is greater than a negative number. Now, a negative number should kind of throw up a little bit of a red flag here. The absolute value is completely by itself, and we've got a negative. The absolute value is always going to be positive. No matter what is filled in for y, it's going to be positive. A positive will always be greater than a negative number. So no matter what we put in for y, it's going to hold true. So in this case, we say y, since it's the variable y, is an element of all real numbers. Or you can just say all real numbers, because any number we put in will work. While we're talking about this special case, let's talk about the other special case. The other special case says we have the absolute value of something, whatever it is less than or equal to a negative number. Well, in this situation, the absolute value will always be positive. And a positive will never be less than a negative number. So if you have something with the absolute value less than a negative number, there is no solution to that. All right, this little example here only works if the absolute value is by itself. So let's take a look at example D. In example D, the absolute value is not by itself. So we can't evaluate whether or not there's no solution or infinitely many. We have to get the absolute value by itself. First, we take care of the 3, and we subtract it on both sides of the inequality symbol. We get 7, absolute value of 3x minus 2 is less than or equal to 63. Then we divide by 7 on both sides. We still have the absolute value of 3x minus 2 is less than or equal to 9. To get rid of the absolute value symbol, we simply break this up. This is a less than situation, so we're going to create an and situation or a compound inequality. In the compound inequality, we have negative 9 off to the left and then 9 off to the right. In the middle is 3x minus 2. We know that 3x minus 2 is less than or equal to 9. It's also going to be greater than or equal to negative 9. But notice that the greater than symbol, because the 3x minus 2 is on the right-hand side, it's still a less than symbol. We kind of did flip it, though. So in this situation, we solve it just like a regular compound inequality. We add 2 to both, or all 3 sides, I should say, all 3 parts. We divide by 3. And we get negative 7 over 3 less than or equal to x less than or equal to 11/3. And again, we can graph this situation. On our number line, we draw the smaller number to the left, larger to the right. We fill in the 2 circles, and we shade everything in the middle. Again, creating an and situation. It was a less than symbol. We think of and or sandwich.